Hello dear friends, welcome to Net Classes CS and Paper 1. Dear friends, myself is Jyoti Kumari Chaube and I am going to teach you computer science subject for NTA UGC Net Computer Science syllabus. And in this series, we will discuss the data communication and computer network system, component of data communication, and what is data communication we have already discussed in previous lecture. And in this lecture we will discuss mode of communication, half duplex, simplex and full duplex system, analog and digital signals, noiseless and noisy channels, etc. Okay, then let us discuss mode of communication. What are the mode of communication system? There are three mode of communication system. In which way we will communicate, how we will communicate, these are called mode of communication. There may be a simplex mode, or it may be half duplex mode, or it may be full duplex mode. Simplex mode is unidirectional and one way, and we can send data in one directional and not in both direction. Okay, this for simplex and unidirectional or one way mode of communication, keyboard is the best example. In keyboard we are sending the message or information or data by typing something, okay, by entering from keys, and keyboard will not receive the data from any source. Okay, then this is called unidirectional. So the total complete capacity of keyboard is used for sending the data, only sending the data. Then this is the benefit can use the entire capacity of source to send the data in one direction. Okay, now we can see that there are TV broadcasting. Okay, in this way we can only receive the data, we can't send or we can't interact. This is called simplex mode. Means, please remember this arrow, this is in one direction and flow of data is in this direction from sender to receiver. This is called unidirectional. Simplex mode, okay, it will be unidirectional, one way, and the entire capacity to send the data is one direction. This is called simplex mode of communication. Now we will discuss the half duplex. What is half duplex? Half duplex system mode of communication is bidirectional but not at the same time. It is evaluated and it is something changed, and we can say that improved version of simplex. Okay, it is improved version, or the uses of both the mode of communication is different. Okay, according to need this classification is happened, and we can use any mode of communication according to our need. Then this is half duplex. In half duplex we can see that in simplex we can see that the flow of data is in one direction, but in half duplex the flow of data is in both direction but not at the same time. Bidirectional but not at the same time. One lane road, example is one lane road. When any construction is going on and the one lane is blocked to use traffic or to communicate or to go through the road, then by one lane road we are using the total system, how to travel from one direction to the other direction. And other example is walkie-talkie. Walkie-talkie is example that in which walkie-talkie you can see that the sender is sending the message, and at the last there is a key, or it is a rule to say over, and after trailing over, the receiver can understand that his or her message is complete, and now the second person can send the data or message or information. So he will start or she will start sending their message after listening, after receiving over message. Okay, so this is called walkie-talkie. At time one, only one directional flow is going to send the data, and after over, the other directional is started. Okay, at a time only one direction communication can be possible. Then this is called a half duplex mode of communication, in which we can use a half side for send data, and after that second side for receive the data. Okay, for communicating. Then we can see that the full duplex is bidirectional and can transmit simultaneously. Okay, in half duplex we are sending the data in both directional but not at the same time. But in full duplex we can send the data in bidirectional mode, and at the same time, all the time we can send the data, just like simple meeting or discussion. All are allowed to send their messages, but in walkie-talkie it is not allowed. And at the same time we can see that the other example, in full duplex both the path link may contain two physical separate paths. Okay, then it is the question, how we will send and receive data from both the side at the same time. Then it is this solution that in full duplex both the path link may contain two physical separate paths. There may be two paths. Okay, and parallelly both are working in the both the direction. Okay, the capacity or channel is divided between signal traveling in both the direction, and it may possible that the capacity will be divided, as we see that in first simplex mode the entire capacity of the sender is used to send the data in one direction. But in full duplex it may be divided in two part. The capacity of the channel is divided between signals traveling in the both direction. This is called full duplex. So please friends, you can see that the flow of data, flow of data from it will be in one direction, it will be in both direction but not the same time, and it will be both direction and all the time. These are the mode of communication. Okay, now we will discuss the analog and digital signal. What are analog and digital signals? Analog signals are continuous and digital signals are discrete. Example, clock with needle or human voice. Our voice is analogous. Okay, clock with needle, we can see that this is the example. It is example of analog and it is example of digital. Binary form has infinitely many levels of intensity over a period of time. There is no a finite or fixed level of intensity, but in digital it is discrete and binary format. 0 and 1 is used for any digital device, from any digital device like wristwatch, BP machine, thermometer, etc. These are the examples. Just like in BP machine we can see that the digital format of presentation. Then we can see that the what are diagrammatic representation of analog and digital signal. Then this is analog, it is continuous, and this is discrete digital, this is discrete, this is either 0 or 1. Okay, simplified communication model. Now we will discuss the simplified communication model. What is simplified communication model? This is, in this you can see that text input information become input data, and input data transmitted into signals, and transmitted signals received signals, and then it will become text or output information. Then this is the process, simplified communication model, in which you can see that it is source, it is destination, it is transmitter, it is receiver, and in between transmission system is present. Then you can see that digital bit stream are sending through to the input data from text source to transmitter, and analog signal, mixture of digital and analog signal go to transmitter signals, and then analog signal again converted in the digital bit, and it will give the text output or information. Okay, this is the simplified communication model, how the bits are converted in between the process of any transmission system. Okay, now we can see that digital data transmission. What is digital data transmission? Digital data transmission is each single bit is represented by a signal element. We can see that the bit, it is the bit, and it is represented by a single element, either 0 or 1, and each signal takes some time to send. Obviously it will take some time, either millisecond, nanosecond, second, any unit of time, but it will take a certain time. It may be higher, it may be lower, but it will definitely take some time to each signal takes some time to send. And bit rate. What is bit rate? The number of bits that can be sent out per unit of time, and the time taken by the signal, and the bit rate, the number of bits that can send out the per unit of time, and this time will be become the unit of the time. This is called data transmission. In data transmission, bit rate and time is used. What is bit rate? The number of bits that can send out per unit of time. This unit of time may be second, millisecond, nanosecond, minute, hour. It may be any unit, but same unit for question and solution both. Okay, we will solve the question in a single unit, or we will convert the data in same unit, and then we will give the answer. And this is digital data transmission. Each signal bit is represented by a signal element, and each signal takes some time to send, and bit rate become the number of bits that can be sent out per unit time. This is called digital data transmission. Now we can see that the noiseless and noisy channels. What are noiseless channel and what are noisy channels? The data rate depend on three factors. What are that three factors? Bandwidth available, level of the signal, we use the quality of the channel. These are the three factors on which the data rate depend. The bandwidth available must be higher or must be in proper area so that the data can transmit. And the level of signal we use, what is the level of signal? This will also affect the data rate. And the quality of the channel, which medium we are using, coaxial cable or there are so many optical fiber and etc. Then the quality of the channel is also called medium. Then what is the quality of channel? And this will also affect the data rate. So we can see that the data rate depend on three factors: bandwidth, level of signal and the quality of channel. A very important consideration in data communication is how fast we can send data in bits per second over a channel. It is an important consideration. Then obviously we will try to send the data fast, and we will try to save our time and medium and resources, and it will be definitely saved by saving our time and doing the work fast. So it is important. This is called data rate. The data is passing and it depend on the factors, some factors. There are three factors. Then noiseless channel. What are noiseless channel? Noiseless channel is Nyquist bit rate. It is named by Nyquist bit rate. The formula of bit rate is 2 into bandwidth into log base 2L. Then bit rate is in per second, bandwidth of the channel, and L is the number of signal level used to represent the data. Increasing the level of signal may reduce the reliability of the system. This is a note. Increasing the level of signal may reduce the reliability of the system. Then how can we understand the increasing in the level of signal? Yes, level of signal means if we are using so many levels, then it will be definitely become lighter or poorer in between the transmission. So we will try to use minimum level to maintain the reliability of the system and not to increase the level of signals too much. Okay, example is 4 Mbps is equal to 2 into 1 megahertz log base to L is equal to 4. This is the example. I will also solve the question on this topic, these formulas. Then this is called noiseless channel, but it is not possible. Noiseless channel is not practically possible. There must be a noise in between the transmission of data. Okay, you will remember that, you will definitely know that the noiseless channel is not possible. Noiseless channel is only imaginary. It is not practically possible that there will be any noise in between the data transmission. Now come to the next point, bandwidth. What is bandwidth? Measures the network performance. how we can perform the network, how network is working good or not, or in which condition, then we will use the bandwidth. Okay, is it visible? Yes. Then note that bandwidth can be used in two different contexts. We can use it in hertz and we can use it in bps, bits per second. Okay, generally we are listening that kilohertz, megahertz, etc in hertz, and also we are listening that mbps, kbps, bps. Okay, then both are the way how we are measuring our bandwidth. The measure, how we can measure our bandwidth is the network performance. We are measure the network performance is bandwidth. Okay, bandwidth can be used in two different contexts. We can already we have discussed this. Bandwidth in hertz, bandwidth in hertz, bandwidth in bits per second. Range of frequencies in a composite signal, or the range of frequencies that a channel can pass, is called bandwidth in hertz. And 4 kilohertz is 56,000 bits per second. 8 kilohertz is 112,000 bits per second. Refer to the speed of bit transmission in a channel or link. Bandwidth in bit per second refer to the speed of bit transmission in a channel or a link. Bits per second. Okay, here we are using the unit second. It may be differ mbps, gbps. Okay, then according to situation we are changing the unit, but here bandwidth in bits per second refer to the speed of bit transmission in a channel or link. How many bits per unit are transmitted between the in between the channel or link from the link. So I think that you can understand the what is bandwidth, and I will show you the image of bandwidth. Then you will clearly understand the bandwidth. What is bandwidth? This is image. This is the image. You can see that the comparison for best explanation of bandwidth and throughput. Bandwidth will be definitely high and throughput will be low, or it will be high and it will be great and it will be less. Then let us discuss throughput. What is throughput? This is image to understand or imagine how bandwidth and throughput are related to each other. Then let us discuss the throughput. Throughput is measure of how fast we can actually send data through a network. Okay, this is throughput. Throughput is a measure of how fast we can actually send the data through a network. It is actual result, and bandwidth is a potential measurement of a link. This is potential, but it is actual. Throughput. The throughput is an actual measurement of how fast we can send the data. Now you can differentiate between bandwidth and throughput. Throughput is actual and bandwidth is potential. Now you can see that how much bandwidth we are using. We are using so many sources for our preparation and studies, and the result of the studies and preparation will become lesser than our sources, isn't it? Then bandwidth will be definitely high and the throughput will become 5 times lesser and 6 times lesser and many more times lesser than bandwidth. Then you can see that bandwidth will be always high and throughput will be always less. Comparison for best example of bandwidth and throughput. You can see that this is throughput. This is a question. Here we can see example. A network with bandwidth of 10 Mbps can pass only an average of 12,000 frames per minute with each frame carrying an average of 10,000 bits. What is the throughput of this network? Then what will be the throughput? Throughput will be number of frames into number of bits. Because from the transmission media frames are traveling and the bits are inside the frames, then we will multiply it, and the unit, a network of bandwidth of 10 Mbps can pass only average per minute. Okay, the unit is per minute, 12,000 frame per minute, then 12,000 by 60 and 10,000 bits per frames. Then we will multiply it by 10,000 and 12,000 into 10,000 by 60 because per minute, because of per minute. Then 0 will be cancelled by 0, 6 will cut 12 for 2 times and 2 and 30 from here, 30 from here. This is called Mbps, megabits per second. Okay, the throughput is almost 1/5 of the bandwidth. As I already told that the 1/5 or 1/6 or 1/4 it will become variate, but it will become lesser bandwidth and throughput. Now latency. What is latency? You can see that latency, how long it take for an entire message to completely arrive at the destination from the time of first bit it send out from the source. Okay, when first bit getting started to travel through any transmission medium, from that time to the complete transmission of the data is called latency. Okay, latency is made of 4 technique components: propagation time, transmission time, queuing time and processing delay. Then what is propagation time? Propagation time is distance by propagation speed, how much distance you are covering and what is the speed. Okay, you can simply think that d by s, distance by speed. Okay, this is called time. T is equal to d by s. And transmission time, message size by bandwidth. Transmission time, what is the bandwidth through which the message will pass, and transmission time, message size by bandwidth, size of message by bandwidth. And queuing time, the time needed for each intermediate or end device to hold the message before it can be processed. It is not fixed factor. Queuing time, the time needed for each intermediate or end device to hold the message before it can be processed. It is queuing time. And bandwidth delay product. What is bandwidth delay product? Number of bits that can fill the link. Number of bits that can fill the link. Bandwidth delay product. Cross-sectionally we can see that in image. Length is delay. Okay, and volume is BW into bandwidth into delay. Volume is bandwidth into delay, and this is bandwidth and this is delay. The number of bits that can fill the link, the number of bits present in this, from this end to this end, is bandwidth delay product. Now we can see that we have already discussed the noiseless channel, noisy channels, and we will see some example of noisy channels. Shannon capacity. Shannon was a scientist, or you can say that engineer. Noisy channel. In 1944, Claude Shannon introduced a formula called Shannon capacity. 1944, Claude Shannon. We have to discuss it in communication in paper 1 also. So Shannon is there also. And to determine the theoretical highest data rate for a noisy channel. To determine the theoretical highest data rate for a noisy channel. How can be data rate can be transferred to noisy channel? There must be any extra surplus points to measure the exact data, because noise will become in between the transmission of data. Capacity is equal to bandwidth into log base 2 1 plus SNR, signal to noise ratio. Okay, SNR is signal to noise ratio. Capacity of the channel in bits per second. Capacity of the channel is in bits per second, BPS. The formula defines the characteristic of channel, not the method of transmission. Okay, this is note. The formula defines the characteristics of channel, but not the method of the transmission. This is called Shannon capacity, but it is not so much important point of examination point of view, but it is our in our syllabus, so I am discussing here. Okay, then thank you friends. Please let me know how you are understanding these lectures, or are the lectures are beneficial for you. Then please let me know in comment section, and I will cover the next topic, modulation, data encoding, modulation technique, broadband, baseband transmission, multiplexing. You can see that these are the topic we will discuss in next lecture. Till then, take care and पढ़ते रहो और बढ़ते रहो. Okay, thank you friends, thank you.